Hello, dear students. Last time we studied chapter 2, motion without graphs. So we will continue from chapter 2. So today we'll study about two types of the graph. And these two types are distance time graph and speed time graph. So in last lesson, we have studied about the speed, velocity, distance, displacement, and acceleration. So when we combine distance and time, we will divide distance and time, we get the speed. And when we divide change in speed or change in velocity with time, we get acceleration. So it's mean when we discuss distance time graph, so speed will be as a gradient. And when we discuss speed time graph or velocity time graph, then the gradient will be acceleration. So there are two cases of speed, like distance time graph. So first case you can see the red line, the second case is purple line. So let's start. First of all, there are two rules. Number one, the time and distance. The time is always taken as x-axis. Usually on the x-axis we take the independent quantities, and the distance is taken as y-axis. So distance is in meter and time is in second, so we'll get the speed in meters per second. So when the object is at rest, so there will be no time, no distance, but there will be constant time, so that we'll get the line parallel to the time axis. So this is the first case. The second case is when an object cover equal distance in equal interval of time. So you can see that 5 seconds and 10 meters. Next 5 seconds, next 10 meters. So equal distance in equal interval of time. So the speed is constant. You can see the distance divided by 5. So 10 over 5 is 2, 20 over 10 is 2. In each case, the speed is 2 meters per second. So the first case is when the object is at rest. So when the object move with constant speed, the car is moving with constant speed at 2 meters per second. Equal distance in equal interval of time. So in each case, we get 2 meters per second. So this is a distance time graph. Very simple. In distance time graph, we use to find the speed. And sometimes the question is like, what is the distance at 15 seconds? So you calculate it, it's approximately like 30 meters. So next one is the distance time graph. It is a question from the book. So you can see that that line parallel to the time axis is at rest, constant speed, rest, constant speed. Sometimes the speed is higher, sometimes the speed is low, but overall, the speed is constant when the line is steep. Next one is velocity time graph, the second graph. And this graph is important because in this graph, we calculate the acceleration as a gradient and the most important, the distance traveled by the car or traveled by the object. So again, same rules. Time axis taken as x-axis and the speed is taken as y-axis. Speed is in meters per second and time is in second. So let's suppose the time is in second, 5, 10, 15, and speed is like 10 meters per second, 20, 30, 40, a constant. So first of all, you can see the first line, this one. So this line indicating the acceleration, because this gradient is acceleration, speed or over time is acceleration. So in equal distance, in equal, sorry, time, equal changing speed. So speed is changing equally. So that's why acceleration is constant. And when the acceleration is constant, so we'll get, the speed should be changed, because when the speed will not change, the acceleration will be zero. In this case, when the speed is constant, the change in speed is zero, so acceleration will be zero. So at this case, acceleration is zero. So in first case and third case, the car is accelerating, but in first case, the acceleration is positive, accelerating, and the second one, the acceleration is negative, that is decelerating. So speed is decreasing. In first case, speed is increasing. The second case, speed is decreasing. Whenever want to find the acceleration, just for example, I want to find the acceleration at this point from it for this line. So what will I do? I will find the gradient. And you know what are the rules to find the gradient? Y2 minus y1 divided by x2 minus x1. Y1 and x1 both are zero starting from origin. So 45 divided by 10, the acceleration at this point is 4.5 meters per second square, as the unit of the acceleration is meters per second square. Now, the most important thing, how much distance is covered during this journey? Like we have the trapezoid. So there are two ways to find the area under the graph that will be represented as distance. So whenever we calculate the distance from speed time graph or velocity time graph, so we use to find the this area under the graph. Okay, so what I did, I divide this shape into three parts, two triangles, one rectangle. So we know that the area of the triangle is 1/2 times base times height. So for A1 and A3, that base is same, the height is same. In both cases, the area is like 225. So for A3 and for A1, the area is 225. For the A2 rectangle, you know that the length into width. So 25 minus 10 is 15. Is base like width is 15, the length is same 45. So 45 times 15 is 625, 75. So now we will add all the areas, all the distance. So we'll get the total distance traveled by the object, that is 1125 meters. So meters is the unit of the distance traveled. So that's why the speed time graph or velocity time graph is important. So we can find the acceleration and we can find the distance from this graph. Okay, the next topic is falling objects under the action of the gravity, or like free fall acceleration. We know that when the object is fall under the action of gravity, so there are two forces act on it. Number one, when the object moving downward, its weight. And when the object is moving downward, obviously in opposite direction, there will be air resistance. So any object fall under the action of gravity, it is independent of mass because a gravity act on the same object. It was the Galileo who discovered that from the Pisa Tower of Italy. He threw different objects of different masses. He concluded that each object will hit the ground at the same time. So it's mean the gravity acting on the object is the same. That is 10 or 9.8 Newton per meter, or the value of G, that is gravitational acceleration. According to Newton's second law, force depend upon acceleration. So it's mean where there is a force, there will be acceleration, and that acceleration due to gravity is called gravitational acceleration. Its value is fixed, 9.8 meters per second, or you can take in IGCSE, you can take 10 meters per second square. So I give you the example like 0.5 kg and 2 kg are thrown at the same height when they will hit at the same time with the ground. So because the acceleration acting on them, that is 9.8 or 10 meters per second square if we ignore the air resistance. So this is the acceleration due to gravity, 9.8 meters per second square. When the object is moving down, so acceleration is positive, that is plus 9.8, because acceleration in the direction of gravity, in the direction of force. But when the acceleration and gravitational force are in the opposite direction, when the object is moving upward, thrown upward, the acceleration will be negative. So this is the acceleration due to free fall. The next one is terminal velocity. Terminal velocity is very important in IGCSE. Its definition, its concept is very important in this graph. What is terminal velocity? Terminal velocity is constant velocity. It may be maximum constant velocity. It may be the minimum, like highest constant velocity, what do you say, the lowest constant velocity. For example, if someone jumped from the aeroplane and he's moving down without parachute, when he is moving down, the acceleration acting on that object is constant. It's mean its speed is increasing. But after some time, when the speed is increasing, at a time the force of gravity and the air resistance will be equal. So I give the example here. You can see the arrows, the length of the arrows represent the amount of force. So in each case, the weight is equal, which is obviously W is equal to mg, because g is affected by the height, but not too much height. Like aeroplane is not too much height. So G is constant, M is constant, so W is constant, but the air resistance increase with the speed. So at a point when the air resistance is equal to the weight of the object will move with constant velocity. So you can see that in the first case, without parachute, object is moving with constant velocity. Constant velocity means the velocity is not changing. So in this brown color, you can see the constant velocity is called terminal velocity. And when they open the parachute, the velocity suddenly decrease because air resistance will increase. Because of parachute, the object will move upward, and then the again the same case, the weight and the terminal velocity again constant. So sorry, air resistance will be equal, so speed will be constant. At this speed, constant speed is also a terminal velocity. Terminal velocity may be maximum, terminal velocity may be a minimum. So there are two terminal velocities, without parachutes and parachute. So this is our second chapter. We completed our second chapter. In next video I will explain the third chapter. And if you have any question, you can ask in the comments. And if you need this lesson in PDF, so you can drop your emails in the comments. I will send it to you. Goodbye.